everyone. Good afternoon, and welcome to the second day of Devops. And today we have a talk of Sasha Rosenbaum about SRE managed services and the path to the future. And Sasha leading adoption of OpenShift, currently with huge and large enterprise customers. Sasha, hello, how are you doing?
Hi, I'm doing well, thank you. And I was at this conference last year, and it was so much fun that I decided to come back.
Yeah, it's so great to have you back. And your talk will be about the future, but for the start, can you tell us a bit more about your past and your experience with DevOps and SRE?
Yeah, so I've been in the tech industry for 16 years. I can't believe it's been that long. Like, I feel really old saying that even. So I got involved in a little conference called Devops Days in Chicago in, wow, I think it was 2014, if I'm not mistaken. And
Wow.
so yeah, it was a while ago. And so, like, back when we started, we were like the fourth city to do the conference. And now it's all around the globe and people are super, super into it. So we've been talking about DevOps for a long time. And we've been talking about DevOps before it was a job title. And then we tried to tell people not to make it a job title. I actually talk about it a little bit in my talk. But then it happened anyway. And then it evolved into other things such as SRE. And now people talk about, monitoring, observability, like chaos engineering, all sorts of cool stuff. Right. And it just kind of an evolution of tech. I think it's, it all starts with the same ideas, but then it progresses and gets more meat on it, gets more good people involved in more practices for implementation.
Yeah, sounds great. So you did DevOps before it was a mainstream.
I did DevOps before it was cool. Yes, for sure.
That's really great. And I know you also speak Russian, and we will have our discussion after the talk in Russian, right?
Yes. So the Q&A can be in Russian. I'm going to give the talk in English because otherwise I have to translate myself and it's really hard. But we definitely can have the Q&A in Russian. Also, by the way, last year was one of the best Q&A experiences I've ever had in the virtual conferences. So like that's part of the reason I'm coming back, because it was kind of a very exciting discussion.
So yeah, everyone, feel free to jump to discussion after the talk. And I'm like really thrilled to listen to you right now. How about we get started?
Okay, I can do that. All right. So this is a talk about SRE, managed services, and the path to the future. And we're also definitely going to talk about DevOps here. So just okay. So let me introduce myself. I started as a dev, so like I have a degree in computer science, and I started as a developer. And then I did do some ops at some part of my life, which involved like being like very much a sysadmin, running backups in a data center and stuff like that. And then it kind of gradually evolved into this idea of DevOps, and I got again, to be friends with some awesome people who were driving part of this conversation. Then I was a consultant for a number of years, and my company was attached to Azure Cloud. So I was working a lot with Microsoft technologies. And then it kind of evolved into me going to work for Microsoft for about half a decade, which was also a long time. I briefly did DevRel, and I spent a lot of time in kind of customer success, so driving adoption of cloud and now OpenShift. And I usually ask the audience who they are. So since we're remote here, you could post it in Telegram if you want, in terms of, are you dev, are you ops, are you security, what do you identify as in your life? So this talk I'm going to quote this book a lot, right? So it's Site Reliability Engineering by Google. It's the first one, right? And I think it's actually really good and very much worth reading. But before I jump into quoting them a lot, let me start with a sentence I appreciate the least out of the entire book. And that's, SRE is what happens when you ask the software engineer to design an operations team. And I think this is a very wrong sentence, right? This is my face when I read this, because the definition is kind of very classist. It assumes that developers are better than ops people and that ops people couldn't figure out how to automate things. And then Google had to ride in on a white horse and save the day. The definition I like better is that SRE is roughly Google's implementation of DevOps. That definition is also in the Google SRE book, so I didn't make it up. They actually say it themselves. So, of course, if we're going to talk about SRE being implementation of DevOps, we have to start with what the hell is DevOps. So, DevOps is about, and there's so many definitions floating around in the past. It's been 12 years, I think, since the first conference. I think it's about transforming culture and automation to align incentives between teams and deliver better software faster. So there's a lot of automation in DevOps conversations, but there's also a lot of conversation about culture and making teams work together jointly and be aligned in how they build software. Now, I want to come back to 2014, 2015, the first 2 years we organized DevOps Chicago. That is the picture of organizers, right? And I'm the only person in that picture who identified as a dev. Most of the other people identified as ops people, right? Very hardcore data center or sysadmin type folks, right? And all they wanted in life was to automate themselves out of a job. So Google did not invent automating people out of a job, right? Like we wanted to do it ourselves. But before we could automate things, take a look at what things look like in the 90s. And I don't know if all of you were born in the 90s, but this is about what it looked like. So getting a new server up was an endeavor that took about 3 months because you had to actually submit an order, you had to write up a budget, you had to procure a physical server, you had to install it on the rack, you had to wire it up, all of these fun things. And usually so if you wanted to run a very simple web application, your process could take months to just get the hardware that it could run on. Backups were on tape. People literally went physically to the data center and they inserted the tapes and then they run them and then they shipped that to a separate location. Restoring things from backup was impossible because you had to go to the separate location, go dig up your backup, hope that it wasn't corrupt and stuff like that. Usually restoring an application that blew up from backup could take more than 24 hours. So it was lots of fun things. I love this tweet it's by William Harold, and he says, "I don't know, but I have a misguided nostalgia for getting a page and driving to our data center to physically restart a server in the middle of the night." And that is the thing that happened, right? We actually went into the data center and we rebooted servers when things didn't work because it was kind of the only way to restore some applications. Right? And so it's really hard to produce reliability when this is the kind of the only way you can deal with problems is by actually physically going someplace and rebooting a server. Also, software release cadence looked like this. I'm picking on SQL Server, but usually, that was largely all the companies. You can see that it took about 2 years for people to release new versions of software. Right, that was the release cycle, and then developers went into a bunker for 2 years. They assumed things about what customers want, and then they implemented that, and then they released it in 2 years. And they, of course, missed the mark to some extent. And then they had to basically release updates, which also took 6 months. So that was their life. Merging, so there was a lot of merge hell going on because people worked on different development branches. Nothing was ever merged into the master. So basically all of these things just took lots of time to merge. And this GIF is here just because I like it. But basically sometimes it took days or weeks to just merge all the development branches together and get the code to work together. And then you ship the version, you officially put a version on DVD that barely worked, right? And then you shipped it to customers. That like is a very much story of our life kind of story from the before days. And then downtime, like system maintenance downtime, was a completely normal thing, right? You just took an application offline for a couple of days and that was fine. And in these couple of days, this is where like everything got put into production and nothing worked. And the ops people had to have all the headache of making changes that, again, developers never tested in production. So just out of curiosity, if you had a couple of maintenance windows like that, how many nines was that? So that was less than 2 nines, because 2 nines only gives you 3.65 days a year. And so we're talking here about planned maintenance taking you down for less than 2 nines. So unavailable systems were estimated to have cost American businesses $4.54 billion in 96. So this is just here for perspective. It's a number, right? But we took applications offline a lot in these days. And we used to think that speed and reliability basically did not agree with one another, right? So you could either have speed or reliability, and devs wanted speed because they were incentivized to build new features, and ops wanted reliability because they were paged at night when something didn't work. And the most times that something didn't work was when developers released an update, right? So consequently, ops people kind of hated change. In 2009, there was a first DevOps Days conference in Ghent in 2009, started by Patrick Dubois and some other very nice people. And that was the first time someone made up the word DevOps, right? And actually 6 months before that, but whatever. It was the first time people started talking about aligning incentives between developers and operations, actually gave it a word, right? And words matter. Then it grew to this major global enterprise, in part thanks to Bridge Cromout, who was the head of Devops Days global organization. It's a nonprofit, by the way. We're all volunteers. It grew to lots and lots of events around the globe because people cared about solving these problems. And these problems were true for many organizations. And then we started kind of researching the metrics. So Nicole Forsgren and team started releasing DevOps State of DevOps report that said that lead performers not only move faster, but also are more reliable, right? So we used to think that speed and reliability are on the opposite side of the aisle. But in truth, software kind of works like a bicycle, right? That if you ride the bicycle too slow, then you actually lose balance and you can't go forward. And software is kind of like that. We want to slow down when we don't know what we're doing. When things are not going well, we intuitively want to slow down. But the truth is, we have to go at a certain speed to maintain our balance and to be good at this. And then the other analogy I also like is software delivery is like a muscle, right? So the more you use it, the stronger it gets. So in reality, a lot of orgs shy from pain, and so they shy away from deploying to production very often. But the more you deploy to production, the better you get at it, and the less it breaks when you do. So the one of the important parts of this talk is that, we couldn't have come up with SRE 20 years ago because the grounds weren't set up for that, right? And this is because effective automation requires consistent APIs. If every server in every location looks differently and every application in every location looks differently, and it's all custom made, you can't automate it because you don't have a consistent API to talk to. So this is like one of the themes of this talk. APIs are a huge, huge important thing. So let's get started with operating system level APIs. So With Linux, we're kind of lucky, right? Linux is a file-based system. And so everything that you do is in files. So you can always write to files, right? And that means you can basically always write a script to automate parts of Linux. But Linux was only 27% of all the server market in 2000. And that's a random year because I could find the stats, right? Windows was 41% of the server market in 2000, and it's an executable-based operating system, and it maintains configuration in the registry. So for Windows to have an API, Windows needed to implement an API. Otherwise, there was just no way for you to automate this writing to registry, because Windows was all about Windows, about clicking buttons, right? Windows was all about UI. Now, this brings me to one of my favorite transformation stories, and it's the story about Jeffrey Snover and PowerShell. So PowerShell is a configuration management framework, CLI, and scripting language, and it shipped with Windows in 2006. But before it shipped with Windows, Jeffrey Snover went through about 5 years of very angry Windows executives yelling at him, "Which part of effing Windows do you not understand? Admins don't want CLIs," right? So Windows was all about GUI, and we didn't want to ship any kind of automation and API with it. Luckily, the world has changed, and the world demanded that Windows could be automated. So another theme of this talk is every wave of automation enables the next wave of automation. So we come next to infrastructure level APIs. And so if we quote the Google book for a minute, it's talking about Borg, which is a Google cluster management manager, which runs most of Google's infrastructure. Central to its success and its conception was the notion of turning cluster management into an entity for which API calls could be issued, right? So again, we want to automate the process of deploying the server so it doesn't take 3 months anymore. We want to automate the process of rebooting, of updating, of releasing, of turning off servers that don't work anymore, so that a human doesn't have to drive to a data center and reboot a server. And Google wasn't the only company. Amazon, Azure also was releasing very similar things, because everybody was under pressure to deliver adaptable services and scale. Now, these companies like Microsoft and Google could afford to build their own custom server racks, right? They could afford to have consistency for the price of money, because they could just basically go into the data center, order a custom spec, and then make all of their servers look alike and behave alike. But that wasn't the case for most of the enterprises out there. And so the other thing that happened that was a major part of this transformation is that companies started to release infrastructure as code. So Puppet was the first one, then Chef, Ansible came around. Now there's about 10 more of these. But basically, it's about letting people who have non-custom, right, like kind of diverse infrastructure, automate their infrastructure deployments and consistency and state and stuff like that. So as we said, every wave of automation enables the next wave of automation, which brings me to SRE, as in Devops Implementation. And I'm going to take a sip of water. So we got into SRE, and honestly, at first when the book came out, I was thinking that, some people wrote down some things and gave it a new name, and now, we just want to be cooler than DevOps. But in reality, the SRE book documented some of the concepts and kind of gave them procedural understanding, so that people who don't work for Google can actually learn from that. And I'm not saying that every practice that Google does is applicable to every organization out there, but codifying practices and putting them down in words actually matters and lets other people learn from your experiences. So the other important theme of this talk is incentives. So SRE, if you read the first part of the book, is all about incentives. So let's first start by definition of what toil is. So toil is the kind of work that tends to be manual, repetitive, automatable, tactical, devoid of enduring value, and that scales linearly as service grows. Right. So if we take the example of William driving physically to the data center, imagine that you had 10 servers. Okay, you could drive to the data center and reboot them. 100 servers still could drive to the data center and reboot them. But what happens when you start having 10,000 of servers or 100,000? Then you need to scale linearly with putting more humans on call so they can drive to data centers to reboot servers. And that doesn't work at scale. Doesn't work at scale of Google, and really makes it really hard to work even at scale of much smaller companies. So what Google said is that it's going to enforce limitations on Toil for SRE team. And if we take SRE as the team that is not quite ops and not quite dev, right? It's the team that sits in between them. They are incentivized to do under 50% Toil. Notice it's not zero. So to be able to effectively automate things, you need to actually learn what needs to be automated. So you need to get your hands dirty and actually do some manual work and actually be on call and actually face customer problems, right? And then you learn what needs to be automated, and then you can go and write down the automation. And it's self-assessed and self-reported, but it must be enforced, because if you don't enforce the limits on Toil, the team will basically turn into on-call team, into like just a generic ops team that is doing most things manually, right? You have to give people time to actually write code. At the same time, it's not 100% about writing code. Next concept, and this is also an important one, is SLIs, SLOs, and SLA. Now, not everything in this in those definitions is new, right? SLA is something that we've had for decades, right? SLA is service level agreement, and it's financially backed availability. So when I spin up a new service as a vendor, I say it's going to be available a certain number of nines, right? A certain number of uptime. And then I promise people to pay them back some money if my service is actually down. SLI is also kind of not a new concept. It's actual availability. So for me to know if I'm at my SLA, I need to actually measure and have metrics on my actual availability. So this is service level indicator, by the way. And I can actually then report on the metric. If I'm not looking at the metric, my stuff is broken, right? I need to look at this metric. Now, the new one is SLO, and that's service level objective. And this is business approved availability, right? Why this matters is that it creates a new incentive. It creates a new alignment between two different teams that didn't exist before. Because beforehand, the business demanded 100% availability. Now, 100% of reliability is unattainable, unnecessary, and extremely expensive, right? If we come back, not even 100%, but 5 nines, 5 nines gives you about 5.26 minutes of downtime a year. Okay, that's all you got. And $1 million question is, will your users even notice? And the resounding answer to that they will not, because the internet service provider background error rate is up to 1%. And so you are up to can go down 1% of the time, which is a lot more than 5 nines, right? Just because your internet provider had a hiccup in the network connection. So your users could not load your service, even though your service was actually up, right? So we're aiming here to exceed something that will never become the actual user experience. SLOs are about aligning incentives between business and engineering, right? So we now can start this conversation about what it is that we're actually aiming for. Now, there is another concept that goes hand in hand with that, and that's error budgets. So error budgets are the acceptable level of unreliability. And so error budget is 1 minus the SLO. And so let's take an example. error budget is 1 minus, say, we're aiming for 4 nines, and it's 0.01%. And that gives you 13 minutes a quarter, not a year, a quarter, right? 13 minutes a quarter is a legitimate level of downtime that you can do things in, right? When you release your new service, when you release an update and you take the service down for a minute, that's in those 13 minutes, right? And that gives you some wiggle room in terms of what you can do. Error budgets are about aligning incentives between developers and operations. How does that work? Well, if developers are measured on the same SLO, then when the error budget is drained, developers will slow down push velocity to meet the SLO and avoid solid releases. So think about this. If I have 13 minutes of available downtime per quarter, and now I'm down to only 3 minutes left, and I need to release an update, right? As a developer, if I'm getting incentivized and paid bonuses on the same metric as an ops people does, right? Then now I want to actually stall the release, and I want to test it and double test it and make sure that we don't blow out our error budget, right? And I don't lose my bonus, because I want to get my bonus. I want to get that promotion. I want write up that we did this major release that we wanted to accomplish. So again, SLOs and error budgets kind of marry speed and reliability in written down incentives. So instead of basically us just talking about how developers will hog operations, which is cool, we are actually putting incentives on paper to back this up. There's other cool and important concepts. So one of them is monitoring. So monitoring is how you manage your known unknowns, which involves checking values for predefined threshold, creating actionable alerts and runbooks, and so forth, right? So monitoring, again, everybody is familiar with monitoring. Unfortunately, not everybody does monitoring, at least not at the level that's actually useful, right? Without monitoring, you have no way to tell if your service is even working. And that's a major point. I know too many companies, especially if we take startups or like big enterprises that are releasing an app that is not super crucial to the business. They don't even measure the uptime, or they will measure things that don't actually matter, such as CPU thresholds. Do CPU thresholds matter? Actually, no. What matters is your user experience, right? So you also need to look at the right things. And speaking of looking at the right things, you need to have kind of exemplary signal to noise ratio. And what I mean by that is, say your CPU thresholds are actually waking up people at night, right? So like every time my server exceeds 90% CPU for like 1 minute, I get a page at night. I will turn off the pager, right? I will start ignoring these alerts because they are actually meaningless, right? So if you're alerting people on the wrong things, you are going to have bad experience because people will start ignoring the alerts and then will not see the actually important things. And the rule of thumb is actually you page people when things are actionable, right? When the human can and should do something about what's happening. And in all the rest of the cases, you just document what happened. Observability is kind of monitoring plus, in my opinion. Observability is how you handle unknown unknowns by instrumenting your code and capturing the right level of detail that lets you answer any question. So basically, it's about learning things for the future as opposed to for the past, right? And then you can actually learn what happened by looking backwards at these metrics that you're capturing and learning how you could improve your services. Okay, caution. It's important to caution against automation will win all the fights. So I'm going to read these tweets. I mean, yes, automation eliminates human errors in the sense that those errors will now be performed by machines, which is absolutely true. And also automation, how to make mistakes consistently, reliably, and really fast. And that is absolutely 100% true that with automation, you can take down more servers more quickly, right? And that, the most recent major outage happened to Facebook, but we all know every single service out there actually took themselves out by, I don't know, something like changing a DNS for a major zone or something like that, and just literally taking everybody down. And there are many, many examples where automation created for a good reason actually took down major parts of deployment just because some parameter ran wrong or something unexpected happened. The other thing is, I like this joke, but you can invest. You think that you're investing in automation so that you can save time, and it's not always. It doesn't always end up being that way because you need to maintain every automation code that you have. Right, the moment that you've implemented automation, the drift starts. Right, so basically what will happen if you don't maintain your automation is that eventually your service is out of alignment because the service keep releasing new versions, right? And so your service becomes out of alignment with the actual automation, so that can actually cause major problems. So when you think about implementing automation, you need to think about what is actually good to implement automation for. The other one is, why spend 2 hours doing manual tasks when you can spend 6 hours automating it? And that's about kind of automating one-offs, right? If I have something that only happens once or twice a quarter, maybe I shouldn't write an automation script for it and then have to maintain it forever, right? Which is why the toil limit is not 0, because you actually need to know what's important for automation. So there's kind of summary of what I was just talking about. Automation is a highly efficient way to make errors at scale. Automation drift starts immediately, so your service can get out of alignment with the automation unless you maintain it. Automating one-offs is inefficient. And my favorite one is all systems are socio-technical. We make this mistake of assuming that if we only remove humans from the system and automated everything, that everything would be better because every error is a human error. And that's actually not how things work, because all systems that we work with involve both humans and technology. And when you take people out of the system automatically deteriorates. You actually learn physics in the past, right? Entropy always wins. So all things left to their own devices deteriorate into chaos. And so automation isn't end all be all, and we will always have people in the system. So let's talk about what the future is. Of course, I don't have a crystal ball and I can't completely predict the future, but I can take a stab of what I think is going to continue happening in this industry. So this is a good quote by William Gibson, which is, the future is already here, it's just not evenly distributed. And that's absolutely true, because many orgs out there are in completely different places on this kind of journey. So this is a DevOps as a solved problem by someone from Google in 2019. I didn't put the name on it because, quite honestly, it made me mad that someone said that, because, well, Stack Overflow did a developer survey. They stopped doing these questions in 2018, so that's the last data I have. But, there is 4.8% of people who don't use version control in 2018, 8% copying and pasting files to network shares, and another 8% of zip file backups, right? So yay, we're not actually up to speed across all of the organization, even just something that seems as basic as version control. There's also the how often do developers check in code, and there is a never, less than once per month, or weekly, or a few times per month, which is all kind of broken. So basically, we're talking about people not actually checking in code, which is, again, how we land in the merge hell zone. So if knowledge was all it took, we'd all have six-pack abs. What I think kind of fixes some of these problems for the large majority of the industry is going towards managed services, which is what is happening. So, what do we want? PaaS, when did we want it? 10 years ago. Actually, I should have put 20 years ago on this slide, because all we've ever wanted is platform as a service, right? And there were hundreds of attempts to implement platform as a service as a commercial platform, and they were successful. There's a lot of people running on top of such platforms. The problem is that PaaS works if your environment is homogeneous, right? Because effective automation requires consistent APIs. And so once you start getting into the territory where every application is different, it's based on different tech stack, it's implemented in different ways, then you suddenly can't use platform as a service because it requires too much customization. And the moment it requires too much customization, the platform provider can't efficiently run it. So here's the good news. Every wave of automation enables the next wave of automation. And I think, and I'm biased because I work for a company that is basing a lot of technology on top of Kubernetes, but I think Kubernetes is the technology that allows us to create that consistent API experience across the industry. So 85% of global IT leaders agree that Kubernetes is a key to cloud native application strategies. I don't know what happens to non-cloud native application strategies, but we can see that Kubernetes is a clear winner in terms of where people think they're going, at least when they're adopting cloud native. And then, of course, there's open source, which also, so it's part of the reason that Kubernetes is winning, right? Because it was open source and everybody could contribute and everybody could basically have an opinion of where we're going. And again, it creates this standard that everybody in the industry can agree on and leverage. Of course, there's a problem with open source, which is everybody can contribute. And so this is a mandatory CNCF cloud native landscape. There's, I think, over 1,000 products on this slide. Periodically, I retake this picture because periodically there's more services added to it. And so this is basically a real life picture of someone operating Kubernetes in production, right? You have to basically build all these pieces and make them work together. And that is actually hard. So fortunately, we do have good news, right? If you're not in the data center management business, you can now go to the cloud. And if you're not in the Kubernetes management business, you can now go to OpenShift. Again, I am biased because I get paid to have this slide in my talk, but hey, we are offering OpenShift across multiple platforms, and we're offering it as a managed service, which means we provide SRE to people to a large extent. Of course, it's always still a joint practice, but we're not the only ones, right? So like, not to be super salesy, like there is a push that is going towards this across the industry in cloud native organizations. When you want to outsource your infrastructure and platform services, I know that was a busy slide. This one is easier to read. What you want to do, in my opinion, if I were a consumer of such services, right? I want to outsource infrastructure services to my service provider. I want to outsource platform services to my service provider. And of course, I build my custom software applications. So I build it, I run it, right? So basically, if we're talking about this kind of motion towards managed services, important question, do you know how your company makes money? I stole it from Matt Stratton. But anyway, if building PaaS isn't your company's business goal, that I would personally think that you want to outsource your SRE to your platform provider, right? Because there's no reason for you to basically invest all this stuff into something that's becoming a commodity. And this is an important point. So this illustration is from Hans Morvik, basically book on this is a description of rising AI capabilities. And we're talking about, like, this book is talking about AI, but I'm talking about automation, which is a lot dumber. But still, basically, as AI capabilities rise, it's think about it as water drowning the landscape, right? It just raises higher and higher. And so there's less and less kind of jobs for humans. But the same thing happens to in the automation space. So you might think that building Kubernetes skills is really good for your resume, which it is, but also eventually these platforms become commodity, and eventually we want to focus on solving actual business problems. Now, there is a second use case here, which is if building PaaS is your business goal, right? And there are some companies out there that can have that as a business goal. You want to get really good at it, right? So as I said, we used to say that DevOps is not a job title, but the reality of it is that we've actually created new job titles. We went through this whole 12 years of experience of talking about DevOps, and here's what the job market in the DevOps area looks now. It's literally, everything ops, right? And we are automating everything. We're creating all sorts of new jobs. And like I said, in the DevOps Days conferences, we used to basically tell people not to name themselves. One of my friends refused to take a job because the title was director of DevOps, and he wouldn't take the job before it got renamed, right? But then, this was also at DevOps Days, we started doing something that's called TalkPay. And we basically collecting anonymous data about people's level of experience, job title, and then salary, just so that people would know, people who attend would know if they should ask for a raise, basically. And then we noticed that people who were DevOps engineers as opposed to sysadmins were getting paid much more. Right. And this is happening now with SRE too. So industry-wide data, having DevOps in your job title is a good thing for your salary. Now having SRE in your job title is an even better thing for your salary. So the new jobs get people higher salaries and more interesting work. And that's a good thing. And hey, if that's what you're doing, then basically you want to learn as much as you can about SRE. And again, I think Kubernetes is the path to the future. Get really good at what you do and go get paid. I think that's a good idea. I'm going to pivot a little bit onto the Redhead Sre Journey. So running these services is not a piece of cake. Actually, we started with 2 nines, yay. And we gradually kind of got to 4 nines for reliability. And this is still a journey that we're going on. And this is a gradual improvement. Interestingly enough, we're in the same position that most of the people in the industry are, because we're building a service in partnership with the cloud. So it's very similar to what most people are trying to solve out there. We're trying to create reliability in the service that that is underlying infrastructure provider is not us. And then I think I had this slide in my talk last year, which was a totally different talk, but a journey of 1,000 miles begins with a single sprint, right? So basically you start with little things and you try to get them better and better. And then eventually, before you notice, you're reaching some major milestones and reaching some better levels of availability and things like that. Last but not least, I like this slide a lot. Ideas are open source. So lots of ideas in this talk came from other smart people, and hopefully other smart people also take some good ideas from me, which is part of the reason that Redhead started Operate First, which is a concept of incorporating operational experience into software development. It's very at the initial stages, there's a repository out, GitHub repo out there. We're essentially driving it towards sharing SRE best practices and kind of making it into an industry standard. And I think this is a place where you can, get involved and contribute, and also hopefully learn from other people implementing things. So to kind of summarize some of the ideas from the talk, It's all about APIs and incentives. We often forget that people will do what you're paying them to do, right? So if you have a problem solving something and something doesn't work, I would look at what people are incentivized and paid bonuses and promote it for. Um, Resources, something you can, of course, take a screenshot of, but Google SRE books, they're all free online, and you can, download them at that URL or just Google SRE by Google. Operate First is the website that I just mentioned for shared knowledge from Red Hat. Lots of different books. The ones I'm recommending are, the Phoenix Project, the Unicorn Project, Continuous Delivery. It's 10 years old. It's still really cool. Accelerate DevOps for Dummies, DevOps Handbook. There's a new version coming out. I think if you haven't read any of them, I would start with the Phoenix Project. It's just a really cool, entertaining story that also exemplifies a lot of these things. And then, yes, we're hiring, and we're also hiring in all sorts of regions. And we're hiring SRE people. We're also hiring black belts, which is my team. And so, yes, you can apply to Red Hat. And one more shameless self-promotion. I've actually written a book before that was written solely by me that no one has purchased. And now I've contributed to this book. So there's an article in DevOps in this book by yours truly. I promised myself that I would promote the hell out of this one. So, hey, you can buy this book. And thank you. You can find me on Twitter as DivineOps, and I post a lot of cat videos. So if you like cats, you probably will like following me. And I am happy to continue these conversations because I think it's a very important conversation to have.
Thank you. Thank you so much for this talk, Sasha. It was really beautiful, and I love and like lot of places. It's so much memory back. So it was amazing. Thank you so much for the talk. And part of history actually. That type of question for you. When was the last time you changed something in your data center in a server?
Like physically?
Yeah,
Oh,
like physically.
It
I'm
has
just
been.
curious.
It has been a very long time. So I've been working with the cloud since 2011. So that would have to be before that. Um, I mean, like you still rebooted the servers in the cloud though. Like, I mean, now you basically don't. But like, yeah, when Azure first started, there was like reasons. You would be like, okay, I better reboot this thing. Yeah.
Yeah. Server reboot on some periodic basis. Old school best practices.
For sure.
Too many memories. We have a question from audience. Will you share a list of books? And I think presentation will be published together with the talk, and
Yeah.
all list will be available there.
And I will. I don't think it's on my notice. Basically, I have a website which is sasharosenbaum.com, and you can get to my talks from there. I don't think this one is there yet, but I will post it there now.
Okay, cool. And you give a lot of good suggestion for people at the end of the talk. So thank you for it. And you speak about this like elevation on things which is going to commodity. So from your perspective, if like I'm, let's say, junior SRE engineer right now, what I should focus for next 5 years so I will be on top of the wave?
I think
technology or yeah.
Yeah, I think Kubernetes is here to stay. And again, you never know, right? Sometimes things come in waves that go away. And so like you assume that something's going to be really big and it's not going to. But I do think that Kube has like all things right about it to be the next big thing. And so I do think that learning Kube is a good idea. And then learning the concepts, right? Understanding I think this is SRE is all about incentives, right? You can't reach these levels of reliability if you don't talk to humans. So is always not just about technology, but is also about understanding how your organization works.
Okay, cool. Thank you so much. I would propose to move to discussion, and I would love to invite everyone to discussion and continue it there in Russian.
Yes. See you there.
See you there. Thank you so much for your talk. It was really great.